Dear friends, in last video we have seen how t value is calculated to check the significance of difference between two uncorrelated means when large sample is given. In this video we will see how t value is calculated to check the significance of difference between uncorrelated means when small sample is given. For that, one example is given here. In this example, the scores of government employees of urban and rural area in adjustment test are given, and to check the significance of difference between their means, this hypothesis is formulated. There is no significant difference between mean scores of urban and rural government employees in adjustment test, and here N1 is 10, means number of employees in urban area is 10 and number of employees means N2 is here 8, and the total of both is 18, that is less than 30. So sample is considered as small sample, and both the samples are taken from two different groups. So the means obtained by their scores will be considered as uncorrelated means. And in this situation, to find the t value, first of all we have to find combined standard deviation. The formula is this: combined standard deviation. Here SD is not simply standard deviation, but it is for written for combined standard deviation, and the formula is SD equals to in root sigma x1 minus x bar 1 square plus sigma x2 minus x bar 2 square upon n1 minus 1 plus n2 minus 1. To find SD, combined standard deviation, we have to do some primary calculation. It will be done in this way. First of all, the scores of the government employees of urban area are taken in the column, and the sum of all the scores is found, that is sigma x1, and it is found 364. On the basis of this, we will find the mean of the government scores of government employees of urban area, and it will be found in this way. X bar 1 means the mean of urban area is sigma x1 upon n1. Sigma x1 means sum of the scores of urban area is 364, and n1 is number of observations in urban area is 10. That is, now dividing 364 by 10, we will get 36.4. This is mean of urban area. In the same way, we will find the mean of rural area, the mean of the scores of rural area. For that, their scores are written here in columns, and the sum of the scores is found, that is sigma x2, that comes to 261. On the basis of this, we will find mean of rural area, and for that we will use this formula: x bar 2 equals to sigma x2 upon n2. Sigma x2 means sum of the scores of rural area, and n2 is number of observation in rural area. So it will be 261 upon 8, and the mean will be 32.63. Now we will find sigma x1 minus x bar 1 means deviation taken from mean for all the observations of urban area. For that, we will find the deviation in another column like shown on the screen. For that, from first observation of urban area 33, we will deduct the mean of urban area, that is 36.4, and we will have minus 3.40. That is deviation taken from mean for 33. In the same way, second observation is 34, and from 34 we will deduct 36.4 and we will get minus 2.40. Third observation is 39, we will deduct 36.4 from it and we will get 2.6. Fourth observation is 34. From that particular observation, we will deduct the mean of urban area 36.4 and we will get minus 2.4. In this way, from each observation of urban area, the mean of urban area is deducted, and it will be written in the column one by one, and we will get deviations in this way. These are the deviations taken from mean of the observation of urban area. Now we will find the squares of all the deviations in another column in this way. The square of minus 3.4 is 11.56. The square of minus 2.4 is 5.76. The square of 2.6 is 6.76. In this way, square of each deviation is found and written in the third column, and after finding the squares of the deviations of urban area, we will find the sum of the squares of deviation, and the sum of squares of the deviation taken from mean for urban area is sigma x1 minus x bar 1 whole square equals to 232.4. Now we find the deviations of the scores taken from mean of the observations of rural area from their mean in this way, in this column, another column. For that, what is done here, from first observation, that is 40, from it the mean of the rural area 32.63 is deducted, and we have got here 7.37. Then from second observation 31, we are deducting 32.63, and we are getting here minus 1.63. And in the same way, from third observation of rural area is 34. From that, we will deduct 32.63, the mean, and we will get 1.37. In this way, from all the observations, we deduct 32.63 one by one, and we will get the deviation taken from mean. Now we will find the squares of all the deviations taken from mean for all the observations of rural area. We will get the squares in this way. 7.37, the square of 7.37 is 54.32, and square of minus 1.63 is 2.66. Square of 1.37 is 1.88. In this way, squares of all the deviation will be found and will be written in the separate column. At the end, we will find the sum of the squares of the deviations taken from mean of the observations of rural area. It will be 99.12. Sigma x2 minus x bar 2 whole square is 99.12. The sum of the squares of deviation taken from the mean of the observations of rural area is 99.12. Now the primary calculations for combined standard deviation is over now. So we will find now combined standard deviation. For that, this formula will be used as we have discussed earlier, and we will put all the values in the formula, and after solving it, we will get at last in root 31.52 upon 16, and that will give under root 20.72, and the square root of 20.72 is 4.55. That is standard deviation, combined standard deviation. Now on the basis of this, we will find SED, standard error of deviation, because when small sample is given and uncorrelated means are given, then to find SED, standard error or difference between means, this formula is used. SED equals to SD means combined standard deviation into in root N1 plus N2 upon N1 into N2. N1 is 10 and N2 is 8. Now putting the values, and by solving it, we will get SED equals to 2.14. Now we have got already SCD, and we are having means of both the groups. So on the basis of these three numbers, we will find T value, and the formula for t value will be common for all the situation, that is t equals to in modulus x bar 1 minus x bar 2 upon SED. We are having all the values, so we'll put the values in the formula, and by solving it we will get t value 1.76. That is t calculated, that is observed t. We have found it and it is 1.76. Now we have to find degree of freedom df. Df is degree of freedom. When uncorrelated means are given, then to find degree of freedom this formula is used. Df equals to n1 plus n2 minus 2, and n1 is 10, n2 is 8, and the sum of these two is 18 minus 2 is 16. Now we are having df 16 and t value 1.76. After finding df and t value, now we have to refer the t table that is given in all the statistics books. In t table, here t table is given, that is given in two parts because table is large, so it is divided in two parts, and in the table 5 columns are given here. The columns may be more or less in the statistics book. First column df is given. Df means degree of freedom. Under the column heading df, different values of df is given. Our df is 16, so we have to locate 16 in df, it is here. And in the line of df, our df 16, we have to find the value written under 0.05, that is 2.12, and another value that is written under 0.01, that is 2.92. These two values are generally considered to check the significance of difference between means in psychology, education and social sciences. So we have to concentrate on these two values for df16. So for df16, required value for significance of difference at 0.05 level is 2.12, and at 0.01 level it is 2.92. We have to remember these two values because our calculated value is to be compared with these two values. So now we have got these two values, we will remember it. The t table value, required t table value for significance of difference between two means are, as we have seen in the table, at 0.05 level it is 2.12, and at 0.01 level it is 2.92. Now after deciding the required minimum value, t value from t table, we have to compare our calculated t value with these two value. Our calculated t value is 1.76, and it is less than both the table values 2.12 and 2.92. So when our calculated value is less than t table value, then hypothesis is not rejected, and it is concluded that there is no significant difference between the adjustment of government employees of urban area and rural area. So friends, in this way we have seen in this video that how t value is calculated and significance of difference between two uncorrelated means is checked when small sample is given. Now in next video we will see how t value is calculated when correlated means are given. Till then, goodbye.